When we're displaying raster data, we can think about that in two different ways. We can either be showing discrete data, such as this geologic map here, where each of these different colors represents a different geologic unit, or we could be representing continuous data like we're seeing here, where the values would be continuous from high to low as we change in elevation across this terrain. Both of these would be examples of thematic maps that are made with raster data. So for the categorical data, we can have different unique values such as the type of geology or rocks, and we can display each of those with a discrete separate color associated with that. And that would be good for either categorical, such as nominal, or ordinal data. However, if we get into interval and ratio data, like the elevation models that we're seeing here, we can display that in two different ways. One would be to first break it into classes or categories so that, for example, all data between a certain elevation would get this yellow color associated here. Or we can stretch out the data, so we kind of interpolate from yellow to the red here, and we assign a slightly different color to each individual elevation as we move up this mountain range here. That would be an example of a stretched image. So when we're stretching images, we want to make full use of the colors we have available to us. For a black and white or grayscale image, what we can see here is this might be the original image that we have, and this could be the elevation values, or it could be something else. But we're seeing that we're not using any whites here, and we're not using any true blacks here. We're just kind of using intermediate grays. So if we take that range of grays, or the range of values, and we stretch it out so that the very highest values are going to get white, and the very lowest values are going to get black, then we won't get so many of the intermediate grays, but we'll get the whole range through here from white to black. So this is sometimes called stretching, and we're using all of our 256 shades of gray, and it basically improves the contrast of the image. There's nothing in this image that isn't already in this image. We're just seeing it better by the brightness and the contrast. And there's many different ways to stretch out the data, minimum, maximum, or we can use a standard deviation of what those values are. But in the end, we're trying to get something of a better quality, such as this. Another type of image raster we can have is a satellite image or an aerial photograph. These can often serve as the base maps for other maps, but they basically just show what the ground would look like from the air. They're typically displayed using the stretched method so that we can get the most contrast and image enhancement possible. And we can do that to a single raster band, such as shown with this black and white image, or we can combine the red, green, and blue bands. So basically 3 different bands or 3 different layers of raster data, one which was measured in red and assigned to red, one measured in blue and assigned to the color blue for display, and one measured in green and assigned to the color green for display. And then we get this RGB composite of something that's called a multi-band raster, because we're looking at 3 different rasters together, and at each grid cell or pixel, the colors are being blended in order to give us, in this case, something like the true color of the land that we would see from an airplane. This is another very common sort of raster display. This is an indexed color raster. So the indexed color raster is stored as a single band of integers, and each one of these pixels is associated with a red, green, and blue value, which in combination is going to give it this color. So this is a simple, consistent, and method to store data, and it's safe storage space. And in this case here, we're making a map that's mimicking the U.S. Geological Survey quadrangle maps. And we can see some of the colors popular in here, such as the blue for the water and the brown for the contour lines.